Buzz duct accessories. Conductor expansion joints. Introduction. There are different types of conductor expansion joints that are installed in a busbar system. Each type has a defined function to perform and is therefore installed in a specific location. The expansion joints are expected to compensate for variations in length due to thermal expansion or contraction of the conductor, movement of the conductor during abnormal operating conditions such as short circuit, minor misalignment due to dimension tolerance, variation due to minor foundation settlement of connected equipment. They also isolate and attenuate the vibration, serve as a disconnecting links for equipment isolation. The selection, design and installation of expansion joints is critical and depends upon the location and intended purpose where it is installed. Copper laminated expansion joints. Expansion joints made of laminated copper foils are most reliable. These are sturdy and can withstand much higher operating temperatures. The shape of the laminate depends upon the terminal disposition, air clearances, and availability of space when multiple laminates are required to be installed in parallel on the same phase. Thin shims of copper foils are slit to the desired size and clamped in a welding jig for the desired shape. The ends are then pressed and resistance welded to convert the ends into a homogeneous compact solid tab. The tabs are then machined and drilled or punched as per the schedule and subjected to polishing to remove any burrs. It is the practice to slit the shims to marginal oversize so that the dimensions of the finished component can be maintained after machining. The thickness of the finished laminate can be arrived at, knowing the thickness of the shim and the number of shims that are resistance welded to form the laminate. Most manufacturers provide thicker shim at either face of the tab to provide better dimensional stability and to prevent flaking. Silver or tin plating may be carried out at end tabs. This process requires extreme care to prevent any ingress of electrolyte between the shims during the plating process. It may not be possible to wash an electrolyte thoroughly and the same may surface later, resulting in corrosion and green salt formation. Copper laminated flexibles can compensate only in two directions. They cannot compensate for the movement in the lateral direction. Twisting the ends of the laminates during installation should be strictly avoided. Consequently, it is important to ensure that the connecting terminals are aligned at the time of installation and the laminates are not twisted to compensate for the misalignment of the connecting tabs. The typical cross-section of a copper laminated expansion joint installed in a busbar system is 1000 square millimeters or 2 square inches. Braided copper expansion cum flexible joints. Copper braided expansion cum flexibles joints have long been used for end connections to the interfacing equipment. It comprises many flats, ribbons or ropes woven with fine thin copper wires that are inserted and pressed inside a copper lug or tube. The wires are sometimes tin plated before they are woven to form a ribbon or a rope. The lugs can be crimped in line or at any predetermined angle to cater to the specific orientation of the tab. The size of the press will depend upon the size of the finished palm. The copper lug, which is turned into a palm, is drilled to suit the bolting schedule. Silver or tin plating of the lug, if required, is to be carried out before pressing. The main advantage of this type of expansion cum flexible joint is that it can compensate in all three directions. It can also marginally cater to the twist misalignment. The flexibility of this type of expansion cum flexible joint is better with the ropes than with ribbon braids. The expansion cum flexible joints must be manufactured to the envisaged final shape after installation. Laminated aluminium expansion joints. Laminated aluminium expansion joints are installed as conductor expansion joints in the run of the busbar system with aluminium conductors. Unlike in the case of a laminated copper expansion joint, the laminated aluminium expansion joints comprises two solid end tabs welded to a welded laminated assembly. The laminates are slit and a defined number assembled in a jig to obtain the desired shape that is envisaged at the time of installation. The end tabs are cut to size, drilled, if required, as per the schedule, followed by edge preparation. The end tabs are then welded to each end of the welded laminate assembly. The end tabs are then polished. Finished aluminium laminates can be either welded to tabs or bolted as the situation demands to form a conductor expansion joint. It is the normal practice to peel the end aluminium shims on either side to remove surface defects during fabrication and splutter deposit during welding. If required, tin or silver plating of the aluminium laminated expansion joints at the end tabs is undertaken for a bolted expansion joints. This process requires extreme care to prevent any ingress of electrolyte between the shims during the plating process. It may not be possible to wash an electrolyte thoroughly, and the same may surface later, resulting in corrosion and salt formation. The typical cross-section of an aluminium laminated expansion joint installed in a busbar system is 1000 square millimeters or 2 square inches. A single expansion or expansion-cum flexible joint in a busbar system may comprise several laminates or flexibles connected in parallel to achieve the desired rated current and short time rating. The current rating will depend upon the configuration of the assembly of parallel paths. During a severe short circuit or while testing the busbar system for its rated short time and peak withstand capability, the electromagnetic forces between laminates or flexibles of the same phase will be significantly high. The forces will be attractive in nature and will result in the collapse of the laminates or flexibles. This requires careful analysis while designing the length of the laminates or flexibles. Anti-collapsing devices need to be installed depending upon the situation. When the laminates and flexibles also perform the dual purpose of acting as a disconnecting link, the length of the laminate or flexible will depend upon the isolation distance required for the basic insulation level for the rated voltage. Improper design and installation of the expansion joint has resulted in permanent deformation of the joint configuration. Short-circuit forces on long flexible joint can result in a whiplash effect, deforming terminal tabs. Long laminated aluminium conductors are installed in the aluminium extraction pots to enable anode replacement without disturbing the electrical connections. Long copper rope flexibles are used in electric arc furnaces to enable tilting of the electric arc furnace without disturbing the electrical connection. Thank you. For a comprehensive understanding of the theory and practices of busbar systems, it is advisable to read the book An Introduction to Busbar Systems, where contents are organized in a sequence for ease of reading and facilitates cross-reference. Please procure a copy of the book with a requisition to Bala at busbarsystems.net.